Hello, fabulous fifth graders again. Here's page 2 of lesson 5 in the problem set for fifth grade. Miss Matamore, Miss Sauce class, I hope you're doing well, and you guys are doing great with this, considering we're doing it all virtually. Again, Mr. Habecker has a lot more tools to play with when he makes his videos. So on number 4, it says, what conclusion can you draw about 1 cubic centimeter and 1 milliliter? What I can figure out is that if you add 1 cubic centimeter to the water level on the previous problems, it rises up 1 milliliter. So when I add 1 centimeter cubed, or 1 cubic centimeter to the water, so think of what we just did on the previous page, or if we were to drop 1 more ice cube into this and it were to melt, it would add 1 milliliter. So if we add a cubic centimeter, it actually is 1 milliliter. They're interchangeable, okay? Therefore, what we're really trying to get you to understand is that 1 centimeter cubed equals 1 milliliter. Okay, 1 centimeter cubed is the same as 1 milliliter. 1 ice cube when it melts equals 1 milliliter. Okay, that's basically what we want you to remember here. We want you to remember this fact. All right, fish tank problems. We love to give fifth graders fish tank problems because in the real world, we're always filling things up. Pools, fish tanks, pots, pans, and that's what we want to know. Is it going to overflow or do we need more to fill it up? So a fish tank is shaped like a rectangular prism, and it's filled to the top with water. That means it's filled right up to the edge. Will the graduated cylinder hold all the water in the tank? So will this hold all the water? This is 50 milliliters. 1 liter is the same as 1,000 milliliters. So let's figure this out. We know we can figure out the volume of this by doing volume equals length times width times height. The length is right here on the top this time. So the length is 13. The width is right here, it's 8. And the height is 10. So 13 times 8 times 10. So I'm doing it in my head. 8 times 10 is 80. And I can times that by 13. I'm going to come up with 1,040 centimeters cubed. Or I could take it and I could do 13 times 80. Because I know 8 times 10 is 80. And 0, 0, placeholder. 8 times 3, 8, 16, 24. Carry the 2. 8, 9, 10. So I still come up with 1,040 right there. Okay. So I know this can hold 1,040 centimeters cubed, or 1,040 little ice cubes. But what if I melted that? If I melted those ice cubes, it would just turn into the exact same amount in milliliters. So it can hold 1,040 milliliters, okay? And I know on this graduated cylinder, the line's right here, but let's say that spout starts dripping. Let's just say that once you get to this line right here, it's going to start dripping out. So right here, we could fill this up with 1,000 milliliters, but we have 1,040 milliliters. So will all of this, if I take this fish tank and pour it into this beaker, will it all fit? No, because 40 milliliters will actually pour out onto the ground. Okay, think of it as like a pitcher where they pour water into your glasses at a restaurant. So that only fits 1,000 milliliters, and then these other 40 milliliters would pour out on the ground. So the question was, can you pour all the water from the fish tank into the beaker? No, you cannot. No, because 40 milliliters will overflow. All right. Now, for part 6, number 6, a rectangular fish tank measures 26 centimeters by 20 centimeters by 18. So we always give it in length, width, and height. The tank is filled with water to the depth of 15 centimeters. Well, the height is 18, but they're only filling it to 15. So let's draw that out. Here's my rectangle. Then I'm going to draw another rectangle the same size. I'm going to start halfway. I'm going to go halfway up, half that height, straight across, exactly this length, straight down, halfway, So I'm about halfway in that rectangle, and then I'm going to connect them. So if this was my fish tank, looks something like that. I know that this height is 18 according to this. I know that this width right here is 20 according to this. And I know that the front length is 26. But I know that the height of the water is only 15 centimeters. So I'm going to try to draw my water right here. And I'm not really doing a good job of drawing it three-dimensional, but I'm just going to kind of fill it in right there. Okay, there's my fish tank. So I know that the water is really only 15 centimeters. So if the water only goes up 15 centimeters, but the tank is all the way to 18, that means this length right here, or this space right here, to get to the top, or this air space, 15 plus what equals 18? Well, 15 plus 3. So I know that the air space, this part that doesn't have water in it, is only 3 centimeters high, but it's still 20 centimeters wide and 26 centimeters long. What is the volume of the water in milliliters? Okay, well, the volume of the fish tank would be, and just the water, so the volume would be 26 long, 20 wide, so volume equals length times width times height, which equals 26 times 20. And then the height of the water is only 15. So if I multiply 26 times 20 times 15, then I'm going to know that when I multiply that completely out, that I'm going to get 7,800. Because if I do 20 times 15, or I'll do the long multiplication a little bit later. I don't have the multiplication space right here, but you guys can multiply it out, and I'll take a picture of it and post it on the written online for you. I'll have a little more space there. So if we know all this blue water takes up 7,800 centimeters cubed, that also means that it takes up 7,800 milliliters is how much liquid it would be. So it says, what is it in milliliters? So that would be your answer right there, 7,800 milliliters. And then it says, how many liters is that? Well, if I know that 1,000 milliliters equals 1 liter, I have milliliters here, so I'm going from 1,000 down to 1. My number's getting smaller, 1,000 to 1. That means I'm dividing it. So I'm going to take my 7,800 milliliters. I'm going to divide it by 1,000, and I don't have to do long division here. I can remember all the way back to Module 1 where we just, if we're dividing, this would be 10 to the third, where it has 3 zeros, so you're going to push these numbers to the right 3 times. So the decimal was here, 1, 2, 3, which is going to give you just 7.8 liters. So your answer for that is going to be 7.8 liters. That's just a straight conversion measurement problem for you. Sorry about the wiggly camera, I'm trying my best. And then C, how many more milliliters of water are needed to fill the tank to the top? Explain how you know. Well, I know from my drawing up here that I only have the space or the height of 3, so I'm going to do that same volume. Volume equals length times width times height. My length is still 26, my width is still 20, so 26 times 20 times, and this time it's the 3, because I only have 3 centimeters available of airspace that I could fill with water. So 26 times 20 is going to be, well, actually, let me do the easy way. So if I multiply 20 times 3, it's going to be 26 times 60. And if I take 26 times 60 and I multiply it out, I'm going to get 1,560 centimeters cubed, which is the same as 1,560 milliliters. So I need 1,560 milliliters left to fill. I have that much space here. That's how much I can add. And I know that because the remaining part, or the open space in the tank, is 3 centimeters high. So I found, sorry, I'm writing on an edge here. I can't write neatly. So I found the volume of that space. And again, I'll rewrite this on another piece of paper much neater so you guys can read it and check it. I have both linked up on Google Classrooms, and I know Mrs. Saw is also going to link it up on Google Classrooms for you guys. And then last but not least, number 7, a rectangular container is 25 centimeters long, 20 centimeters wide. If it holds 1 liter of water when full, what is its height? So let's just sketch this out real fast, sketch what we know. We know that it's 25 centimeters long, and we know that it's 20 centimeters wide, and we don't know what the height is. So we could put a question mark there. And algebra, they just put letters instead of like boxes or blanks. So if I did volume equals length times width times height, and we knew that the length was 25 times the width, which was 20, times the height, which is, we could leave a blank there, and we could say all of that equals the volume, but right here we know the volume is 1 liter. 1 liter. Well, instead of just leaving a blank here, we're going to use the letter H, and instead of writing 1 liter, we're going to change that into milliliters, because we know cubic centimeters equals milliliters. So right up here, we know 1,000 milliliters equals 1 liter. So I'm going to change that into 1,000 milliliters equals 25 times 20 times H. Now, if I'm timesing these, and I know I'm timesing those, and then I'm trying to find what's happening here, I'm going to times these first. So 25 times 20, think of 20 quarters. There's 4 quarters in $1 or 4 quarters in 100 cents. So if you had 20 of those, that would be 500. So up here I have 1,000 milliliters equals 500 times some height that I don't know. So if I had 5 times something equals 10, I know that I could take 10 and divide it by 5 to find the 2. So just think of simpler math problems. So all we're going to do is do a fact family or a related fact. We're just going to take this, and we're going to take the 500, and we're going to, instead of times it, we're going to divide by 500. So 1,000 divided by 500. 500 times what? 500 times what equals 1,000. So that's going to equal 2. So we know that the height equals 2 centimeters. So the height, I have to write this sideways. It is 2 centimeters. I can't write that very neat. I'm on the edge of the book that's bumped up high. And again, I'll rewrite this and write it much neater on the paper that you see. But that's how you would solve this problem. Thanks, guys. See you tomorrow.